Hello everyone, welcome to Dinesh QL. My name is Dinesh Priyankara, Data Platform MVP and Business Intelligence Architect. This is my second Azure Databricks video. I'll be discussing how to access Azure Data Lake Store Gen 2 through Databricks. There are multiple ways of accessing it, but this video focuses on one of the security principles, which is service principle. I don't have much slides for this video. It's going to be a very short one. Uh, but let me show you what I have added to this video. So I'm going to discuss what are the ways of accessing Azure Data Lake Store Gen 2, specifically for Azure Databricks. And once it is discussed, the next is demo. So as a part of the demonstration, I'll be showing you the way of creating a service principal, and then let's see how the Spark context can be set using this service principle within Databricks for accessing Azure Data Lake Store. Once we establish the context, then let's see how this role-based access control works and how ACL-based access control works. This video does not talk about what is Azure Databricks and why we have to use it. So if you are new to Azure Databricks, please watch my first video, which is Azure Databricks what, why, and how. As I told you, there are multiple ways of accessing Azure Data Lake Store. So if we talk about the models it supports, we can talk about role-based access control, ACL, or you can call it as POSIX-like access control list, or you can use shared key or shared access signature. Let's try to understand these three. Let's say you have a user called Dinesh, and Dinesh wants to access the content of your storage. You have multiple folders, multiple files, multiple subfolders in this storage, but you want to make sure Dinesh can access everything. In that case, the best is role-based access control. How role-based access control works: whenever you create a service in Azure, in almost all services have roles, built-in roles. So if you take Azure Data Lake Store, once it is created, you can see roles like contributor, reader, writer. Likewise, there are multiple roles. So you can make Dinesh as a member of one of these roles. Now let's say you want to make sure that Dinesh can only read the content on this storage. He cannot do any modification. He cannot write new files. Then you can add Dinesh to reader role. Once he's in reader role, then he can read anything in this storage. One problem with this technique is you have no way of giving permission for subfolders or files. It is for the whole thing. Now we know that Azure Data Lake Store starts from the container, and within the container you'll be having folders, subfolders, and files. So this permission will be assigned to the container, and Dinesh will be access everything inside the container. But if you want to make sure that he can access one of the subfolders in your storage, then your choice should be the next one, which is access control list. So you can take Dinesh account and say that he cannot access everything. For example, let's say we have a subfolder called accounts, so he can access only accounts folder. So when you go through access control list, you can mention whether it is going to be a read permission or write permission, or there's another thing called execute. I'll explain that when I do the demonstration. But you can simply assign permission based on folders, files, or subfolders. Now, what is the last one? Shared key and shared access signature. If you do not want to consider users or groups, any principles like that, all you want is just to access the storage, you can simply use the shared key. So you can establish the connection using the shared key, and after that you can do whatever the operation you want to perform, like reading, writing, modifying. Everything is possible. We don't recommend you to use shared key or shared access signature. We always encourage you to use either role-based access control or access control list. Now, when we talk about role-based access control and access control list, we have to talk about security principles. When it's come to permission, we talk about securables and principles. So in this case, securable is Azure Data Lake Store. Principle is security principle in Azure. So we have multiple types of security principles. User, the standard user, like Dinesh is a user. group, you can have AD groups. You can have service principal, you can have manage identity. Now, what is service principal and manage identity? Let's say you want to access this storage without using a named user or named group. This is the option. In that case, you can use service principal or manage identity. Microsoft recommends manage identity over service principal, but unfortunately Azure Data Lake Store does not support manage entity. I'm sure that in future releases you'll be see that support, but for the moment we don't we have no way of accessing Azure Data Lake Store through manage identity. So you have to use service principal in that case. So service principal is simply an identity. You can create a one and set a secret, and then you can use the name of it, or I can say that you can use the ID of it and the secret, or consider the secret as a password for connecting with your storage. Now, service principal can be used with both role-based access control and access control list. As I told you, this video focuses on service principal. So let's see how we can use service principal for accessing the storage with both role-based access control and access control list. So that's the demonstration I'm going to do. I'm going to show you the way of creating a service principal, and let's create a Databricks notebook for accessing Azure Data Lake Store. So as a part of that, I'll be creating a Spark context using the service principal we created, and then let's see how service principal works when we try to set permission based on role-based access control and ACL-based access control. Okay, let's see how this works. So I have a storage account already created and it has some files. I'll show you. And I have already created an Azure Databricks workspace and it has a cluster too. Let me show you my storage first. Let me go to the menu and click on storage accounts. And I have a storage account called the SQL test storage. Let me open it. And this is Azure Data Lake Store Gen 2 storage. Let me show you this storage using Azure Storage Explorer. So this is my subscription. Under storage accounts, I can see my Data Lake Store Gen 2 storage, which is SQL storage. It has one container called data, and it has a folder called native data. If I go into native data, I can see two folders, call data and master data. If I go into master data, this has a CSV file called call accounts. If I go back to native data, inside call data, I have folders for years, months, and dates. So assume that the storage is being maintained for holding CDR records coming from telco towers. Okay. For example, if I scroll down and open the folder related to 2019 June 25th, I can see a CDR file. So if I go back and open the folder related to 26, I should see another file. So this storage is for CDR files. Whenever a new CDR is generated, that file will be placed in relevant folder of this storage. Now, how do I access this storage and process data? Now, processing data using various techniques, that's beyond this video. It's all about accessing this storage. So let's see how we can access this storage using Azure Databricks. Let me go back to my portal and open Azure Databricks. It's already in my favorite list. So let me click on Azure Databricks. You can see I have two workspaces. Let me open my first one, and I'm going to click on launch workspace to open the portal related to this workspace. So as I told you, if you're not familiar with all of these things, watch my first video. Okay, so this is my account. Now what I'm going to do is I'm going to create a service principal for accessing my storage through my notebooks. I have already created notebooks, but before opening and showing the code, let's go for app registration. That's what you have to use for creating service principal. So let's get the account created and let's make a note on ID of it and secret, and then let's come back to the notebook in Azure Databricks, make changes, and let's see whether it can access the storage or not. Let me go to the first tab and I'm going to open app registration. Let me click on new registration. We are going to create a new service principal. So I'm going to name this as DNSQL test app registration. That's a name. And I'm okay with the first radio button and I don't want to fill anything else. Let me click on register. So this creates the account. Once the account is created, first thing I need to make a note on my application ID, and I need my directory ID as well. So let me copy that, and I need to generate a secret for this service principal. So let me go to certificates and secrets and click on new client secret. Expire in 1 year, that's fine. I'm going to name this as Azure Data Lake Store Key. I can see the key, so I need to get it copied, because once you close this blade you have no way of seeing this key again. So you need to make sure you copy it and make a record. Okay, I have everything I need. So my service principal is ready. Now we are going to check role-based access control first. So since I'm going to access the storage using this service principal, I want to make sure that this service principal is a member of one of the roles related to my storage account. So let me go to my storage account now. So when you open the storage account, in your left pane you should see something called access control, IAM. Click on it and you have three sections: add a role assignment, view role assignment, and view deny assignments. So we have to use add a role assignment. Click on add and select the role. So I'm going to select something like storage blob contributor, because I'm going to I want to make sure this service principal can read and write. So I'm not going to just select reader, I'm going to select storage blob contributor. Assign access to, that's fine. Now I want to I have to look for my service principal. I can see it, so let me select it. This is the one we just created, and let me click on save. Now my service principal is a member of contributor role. Okay, so let's go back to the Databricks and let me open one of the notebooks I have already created. But before that, I want to make sure my cluster is up and running. Let me go for clusters. It is not running. I'm going to start it. Okay, so cluster is up and running. Let me go to my workspace, users, Dinesh, and open something called create column master table. Okay, so let me explain the code I have written. So we talk about creating the Spark context. So this is how you have to create the Spark context. Now all it needs is your service principal ID and the secret. So this shows an old ID and old secret. So let me take the new ID and the secret, and all these are a standard setting. Even if you go through Azure docs related to Azure Databricks, you can find this code. Now this has to be replaced. The client ID value has to be replaced with the service principal ID you just created, and this has to be set with the secret we created for that service principal. So let me take those two and put it to this code. Okay, so I set my application ID or the service principal ID and the secret. Other thing is just make sure that this part is getting replaced with your directory ID or your tenant ID. So my one is already set, so I should be able to execute this code. So I'm going to execute this cell in my notebook. Execution is complete, no error. So let me check and see whether I can access storage now. I'm going to execute the second cell. It tries to access the native folder in my storage. This is my storage, and I'm specifically focusing on data container. So let me execute this and see whether it works. No error. I can see all other folders, which mean this works, which mean the Spark context we established with this, it works, and I should be able to access the files. Let me execute the third cell. I'm creating a data frame, and data frame against the caller account CSV file, which is in master data subfolder, and master data subfolder is in native data in data container. So let's see whether we can access this file and set the content of this file to this data frame, and let's see whether we can view data. All good, and we can see data, so which mean the permission we set works well. So in order to continue with my second notebook, I'm going to create an external table pointing to this file. So this is the SQL code for that. Create table, this is the name of my table. So let me execute this code. External table is created. Let's test it and see. Right, I'm getting data when I execute something like select all from master data database dot call accounts table. That's what we created using this cell. I can see records. So these records are actually coming from my call account CSV file, which is in native data slash master data folder. So service principal support us for accessing the storage, and we can access because this service principal is a member of contributor role. Let's see whether we can write data back to the storage. Let me open another notebook I have already written, which is called process CDR. Let me establish the context. I'm executing the first cell. Okay, no errors, which mean it worked. Now I'm going to create a data frame called CDR, and you can see this time I'm accessing a folder like native data, call data, 2019 folder, 6 and 26, and all files. I have only one file, but if it has multiple files, it will take everything. So let me check and see whether this works. Since the service principal is a member of contributor, he should be able to, or this service principal should be able to access any folder in this storage. Yes, so you can see the data set. So this is a very simple CDR format. This is, don't think that this is an actual CDR file. Actual CDR file is much more complex than this. So it's a very simplified version of it. But anyway, so we can access the file. I'm going to do some transformation on this, and then once I have completed the transformation, I'm going to take the result and write the result back to the storage. So this cell is basically for setting the schema. So let me execute this. Right, schema is set, and if I print the schema, I can see the schema is set for my CDR file, like ID, call A, call B, start and end time, duration and sales. So I'm going to make some modification to this. We don't need to worry about all the modifications here, because in this video what we focus on accessing, in this case reading and writing. So let me do all these changes. Right, so I have made some modifications, and I'm going to create a temporary weave on that data frame. So then I'll be able to use this data set as a weave. This is going to be the weave name. Do not worry about this cell. It's all about accessing a Azure SQL database. We don't need to worry about that part. And let's focus on this cell. So I'm going to combine the weave I created with the external table I have created. So you remember with my first notebook, we created this external table, and external table points to the file exists in storage. And this result set has been created using my data in one of the date folders. So let me execute this. All good. And if I check my data set, this is what I have now. So can I write this result set back to the storage? I should be able to perform that task, which is this cell. As you see, I'm writing the output to this folder 2019-626, but not into the original data folder. I'm expecting to have a new folder called CDR process data. Let me go back to my storage explorer. In my storage explorer, I'm in the container which is called data. I have only native data folder. So I want to make sure that new folder is getting automatically created here, and my result set is getting saved inside that folder. So let me execute. This should create this folder and these three subfolders, and this result should be place inside that folder. So let me execute this and see. All good. Let me go back to my storage explorer, refresh. I can see CDR process data. If I go into this, I can see 2019 folder, I can see June folder, I can see 26 folder, and I can see the output. This is how it generates the output, just like Hadoop. So if you want to get the results into a different location, from this you can combine these files, or when you execute the code for writing, you can if you want, which is not recommended, if you want, you can ask Databricks to write everything to a single file rather than writing to multiple files. So all these are part of the way you code. But what we wanted to check was whether we can access, we can read data, and we can write something back to the storage. So it works really well because service principal is part of the contributor role. Now let's check how ACL works. Okay, so this is a notebook I use for accessing my a caller account CSV file and creating an external table. So let me clear the result set, and what I'm going to do is I'm going to remove service principal from contributor role, and then let's see whether we can still access the call account CSV file. Obviously we will not be able to access, and then let's use Azure Storage Explorer for giving permission to service principal on a specific folder. Let me go to storage and view all the permission that have been assigned, and I can see the SQL test app registration as a storage blob contributor. I'm going to remove this. Okay, service principal is no longer a member of contributor role. Let me go back to my Databricks notebook. I'm going to establish the context, running, done, and let me come to the third cell, and let's see whether we have access to caller account CSV file. I'm getting an error. Let me expand this and see. It clearly says that this request is not authorized to perform this operation. So which means this service principal has no permission to access this caller account CSV. Let's go back to the storage explorer and try to give permission on this file to our service principal. Okay, so let me go into native data and master data. This is the file. So let me right click on this and click on manage access. Let me click on add, and I'm looking for SQL test app registration. That's my service principal. I can see it, select it, and add. So I need to select access. I'm going to say that this time he needs only read permission. So let me select read and click OK. Permission is given. Let's go back to the Databricks notebook and let's see whether our service principal has access to this file now. I'm going to clear the state and the result, establishing the connection or the context, done, and let's execute this. But I'm still getting an error. It says not authorized. We are 100% sure that we have given permission on this file, but when it's come to setting permission on ACL, there are some other things you need to consider. We gave permission on that specific file, but this service principal has no access to the container. That's the top level of the storage. This service principal has no permission for folders like native data, master data. So service principal needs to access these folders in order to access caller accounts. So do I have to give read permission for all these folders? No. This is how you have to configure. Let me go back to my storage explorer. I'm going to right click on data and click on manage access. Click on add, look for my app registration, select it, click on add and select access, and not read and write. I'm going to say that execute. That makes sure my service principal can navigate through this container. So let me click on OK. We gave permission to data, but we didn't give permission to native data folder. So let me right click on native data folder. I'm doing the same thing. Search for my app registration, found it, click on add, access and execute. Click on OK. One more thing, because our file is in master data, right click on master data, click on add, look for service principal, access and execute. Completed. Let me go back to my Databricks notebook, clear the state and result, establish in the Spark context, done. Let me see whether I can access the file. Now I can access the file. So this is how ACL works. You notice that if you want to make sure that this service principal wants to access one of the files in one of the subfolders, you have to give at least execute permission for all parents folders. What you have to do is, if you're planning for ACL, just make sure you give permission before you create these subfolders. Then you don't need to worry about assigning permission to individual folders. Let me show you that part. Assume that I have a new folder called native data 2 and master data 2, and that has a caller accounts. So what I'm going to do is, before creating these folders, I'm going to assign permission to the root, and I want to make sure that my service principal will get permissions automatically whenever new folders are created, whenever new files are placed. Let me go to my storage explorer. Let me access data container and manage access, and this is the permission we have set with our service principal. So I'm going to select default and read and execute. So what I'm setting here is, whenever new folders are getting created, I want to make sure my service principal has permission on read and executes for all new subfolders and files. Let me click OK. I'm going to create a new folder called native data 2. Go into that folder. I'm going to create a new folder called master data 2. And I'm going to open that folder, upload a file for this. Okay, file is uploaded. Now we didn't give specific permission for native data 02 or master data 02 or for this specific file. Let's see whether we can access this file. I'm in my notebook again. I'm going to change this path to native data 02 and master data 02. I'm going to establish the connection again. Done, and let's see whether this works. Yes, it worked. Since we have given default permission to data container, that permission will be automatically added to new folders, new files. So this is how you manage ACL. Okay, so we talk about how to create a service principal and how to use service principal for accessing Azure Data Lake's storage Gen 2. We tested role-based access control. We tested ACL-based access control. Everything worked fine. We tested reading files. We tested writing files. So I believe that you understood the way of accessing Azure Data Lake Gen 2 through Azure Databricks. Now, if you want to make sure that your users can access Azure Data Lake Gen 2 without using service principal, you need to make some adjustment in Databricks end. Let me make another video on that, so then you can see how you can make sure that your users can access your Azure Data Lake storage based on the permission they have been given, specifically on ACL based access control. Thank you very much for watching, and if you have any question, please add a comment. I'll answer whenever the time permits.